Those who have joined the class, please give your attendance in the chat box. I repeat, those who have joined the class may give their attendance in the chat box. So it is 2:15 p.m. I will not waste much time. Please give me a second so that I can present my screen. Can anyone please confirm me whether my slides are visible or not?
Yes, sir, visible.
Okay, fine. So I think due to some reasons, last week class could not be held because in mechanical second year lab exam was going on. So I could not able to take the class quite a little bit long time from past 2 3 weeks. So not an issue. So let me tell you that for your mid-sem exam, the syllabus will be the first module. For my part, the syllabus will be the first module. Today, I will discuss two more problems, and with that, we will wrap up this module. And then, from next class onwards, we will actually, in my part, four modules are there. I will start the second module called friction. So, let us quickly today solve the two
Sir,
questions. Yes.
sir, can you please tell the topics? Means in the model one, it would be better.
In the module one, already I have sent the book is there in your Google Classroom. If you see clearly the Google Classroom, I have written also which all chapters you have to follow in for module number one.
Okay, sir.
You follow that Google Classroom clearly. I have written somewhere, or else I can every time I am giving the recorded lectures in the Google Classroom, you can match with those content part. What all things are there? Okay.
Okay, sir.
Fine. If you see, it has been given in the Google Classroom. I have already given that in from that book, which all chapters you have to cover for module number one. Please look the Google Classroom clearly. Okay. So, if you remember, in the last class, we were discussing some problems related to movement of a force. Today, we will discuss two more problems, and with this, we will end up this module over here. After that, I will be left with three modules, and from the next class onwards, I will start the second module, that is friction. Okay. So let us start. Fine. We will solve this question. Let us read the question. What the question is, because if you remember in the last class, we have solved this problem. We have solved this problem. So let us solve the next problem. The problem is a uniform wheel of 600 millimeter diameter weighing 5 kilonewton rest against a rigid rectangular block of 150 mm height as shown in the figure. That means this is a wheel of diameter 600 mm. This wheel is kept against a rectangular block. Height of the block is 150 mm. Height of the block is how much? Height of the block is 150 mm. Okay. Find the least pull through the center of the wheel required just to turn the wheel over the corner A of the block. Also find the reaction on the block. Take all surfaces to be smooth. That means What is basically given to you is that a wheel is there. This wheel is resting on a horizontal surface over on a rectangular block. Height of the rectangular block is 150 mm and the diameter of this wheel is 600 mm. Now from the center point, from the CG of the wheel, that is center of gravity of the wheel, weight of the wheel is acting, and the weight of the wheel is, I think it is given as 5 kilonewton. Weight of the wheel is 5 kilonewton. From this central point of the wheel, a force P is applied. A force P is applied. Force P is applied. What you need to find out? You need to find out that minimum value of force P such that this wheel will get topple over point A of this block, as well as you need to find out the reaction force exerted by this block on this wheel. Is the question clear? Any doubt so far? Hello,
Yes,
please
sir.
answer whether the question is clear or not.
Yes,
Yes,
sir.
sir. Okay, that means what should be the minimum value of this force P so that this cylinder should come over this point A of the block, that I need to find out. And secondly, what is the reaction force that this block is exerting on this wheel? That is RA, I need to find out. So before finding out the value of P and RA, first let us draw the free body diagram. Then the entire structure will be clear. So let us draw the free body diagram of the wheel. Okay. In the problem, it is given that the wheel is having some weight and that weight is 5 kilonewton. So the weight of the wheel will be acting vertically downward. That is, this is your weight, 5 kilonewton, 5 kilonewton, fine. And if you see, this is the ground, this is your ground. From the center of gravity of the wheel, this inclined force P is acting. This is that force P. That means this is that force P. And since the wheel is in contact with this rectangular block A, so this rectangular block will give a reaction to the wheel in this direction. That is RA. This will be your RA. That means, say, this is that RA. Let us assume that this RA is making an angle, how much? It is making an angle theta with respect to horizontal. So if this angle is theta, then definitely this angle is also theta. And this overall distance is how much? 600 mm, that is diameter of the wheel. And this height is how much? This height is 150 mm. So what we can do is from point A, let us draw a horizontal line, parallel horizontal line in such a way that this horizontal line is intersecting this 5 kilonewton vertical line at this point. Say this point is B. So in order to find out the value of force P and reaction RA, first let us find out what is this angle, how much is this angle theta, with which means at which direction this RA is inclined on this wheel. That means we need to find out first this angle theta. In order to find out this angle theta, what I can do is I can consider the triangle AOB. In this triangle AOB, if I take sine theta is how much? Sine theta is perpendicular by hypotenuse. Perpendicular is OB divided by hypotenuse is OA. Again, OB I can write as OC. minus BC. OB I can write as OC minus BC divided by OA. So sine theta is equal to OC. OC is how much? From the figure, can you tell me the value of OC? From the FBD, can you tell me the value of OC?
Sir, 300.
Yes, it is nothing but the radius of the circle. Diameter is 600, so the OC will be 300. So value of OC is 300 minus BC. Can anyone tell me the value of BC from the diagram? What is the length BC?
Sir, 150.
So how it is 150? This BC is nothing but this particular height. Yes or no? This is that BC. This height, because here the block is kept and the height of the block is 150 mm given. So 300 minus 150, that is OC minus BC, we have calculated, divided by OA. So can anyone from the diagram please tell me what is the value of OA?
Sir, that is
What
also
is
300.
OA? OA is how much?
Radius of the circle.
Yes, OA is
300.
also the radius of the circle. That means 600 by 2, 300. So we got all the values. We can easily find out the value of this angle theta. That is, theta will be sine inverse of 300 minus 150 is 150 divided by 300. That is 30 degree. So now it is clear that RA is acting at the RA, this reaction force RA, which is exerted by this rectangular block on this circular wheel is inclined at an angle of 30 degree from the horizontal. So we got the value theta equal to 30 degree. Is everything is clear to you till this much point? Any doubt so far?
No, sir. No doubt.
Okay, other people please respond whether it is clear or not so far. Other people, those who have joined the class, please respond whether it is clear or not.
Yes, sir.
Okay. Fine. So we got the value of theta. Now in this triangle, which triangle? In this triangle OAB. Since it is a right angle triangle, so I can use Pythagoras theorem, that is O hypotenuse square is equal to base square plus perpendicular square. Hypotenuse is OA square is equal to base AB square plus perpendicular OB square. From this Pythagoras theorem, I can get the value of AB. That is, AB is equal to under root of OA square minus OB square. What is OA? OA square is nothing but radius square. That is 300 square minus OB. What is OB? From the diagram, can you please tell me the length of OB? From the diagram, if anyone can tell me the length of OB.
150.
OB is 150. Let us see how it is 150. OC is radius of the circle, which is 300, and BC is nothing but this rectangular height 150. So 300 minus 150 is 150. So AB is under root 300 square minus 150 square. So I got AB to coming out to be 259.80 mm. It is clear to all of you till AB. Any doubt so far? Hello.
No, sir.
Okay, now since what I need to find out, I need to find out the minimum value of force P such that this wheel will topple. Topple means this wheel will move towards point A. That is the meaning of topple. So in that case, if we take moment about point A, because in the question, I need to find that minimum value of force P such that the wheel should topple from point A. That means from my point A is the heart of this problem. So if I take moment about point A, let us and equate it equal to 0, then what will come? Moment about point A. That means force into perpendicular distance. So I can take this force P into perpendicular distance OA, and this P into OA. In this P into OA will try to rotate the entire body in anti-clockwise direction. Yes or no? P into OA. Hello.
Yes, sir.
It will try to move the entire body in anti-clockwise direction. So what I have taken? I have taken this anti-clockwise moment positive. That means the clockwise moment I have to take negative. So this is P into OA. P into OA, and another force is this 5 kilonewton. So force into perpendicular distance, this is my force into perpendicular distance, that means this distance, and this distance is nothing but AB, that is P into AB, and this P into AB is making a clockwise moment. P into AB will try to move the entire body in clockwise direction. Already we have taken anti-clockwise moment positive. So for clockwise moment I will take negative. So minus 5 into AB. See, minus 5 into AB. Is it clear?
Yes, sir.
Yes, sir.
Okay. So we have taken the moment of force P. We have taken the moment of force 5 kilonewton. Will I take the moment of force RA about point A? Will I take the moment of force RA about point A? Yes or no? I have taken the moment of force P about point A, that is P into OA. Anti-clockwise moment positive. I have taken the moment of force 5 kilonewton about point A, that is 5 into AB. It is a clockwise moment. I have taken negative. Next comes the force RA. It is passing through point A. So will I take the moment of force RA? Yes or no?
No, sir.
Why no? You have to give the reason.
Sir, because the body is turning about the block, but the block is not doing anything to turn the body around the block. So we will take into the zero. We will take the force into zero.
Your explanation is not that correct. See, if the body is rotating about point A, that means I have taken moment about point A. So if you see this point A, this RA will have two components. One is RA cos theta along this direction, another one is RA sin theta along this direction. What is the formula of moment? Moment is force into perpendicular distance from the point of application of force. Here the point of application of force is point A. So from point A, whether you take RA cos theta or you take RA sin theta, is there any perpendicular distance? Is there any perpendicular
No,
distance?
sir.
There is no perpendicular distance. So I will not consider the moment of force RA. Always remember, whenever you are taking moment from any particular point, from that point just check it whether any perpendicular distance is possible or not. If it is possible, then only the moment will come. If the distance is not possible, moment will not come. So I will not take the moment of this force RA about point A. I hope now it is clear to all of you. Okay, so P into OA minus 5 into AB is equal to 0. So P into OA, what is OA? OA is nothing but radius of the circle, 300. So P into 300 minus 5 into AB. AB just now we have calculated By this process, we have just now calculated AB, that is 259.807 mm. So if you solve this expression, you will get the value of P, which is 4.33 kilonewton. So if you apply a force of 4.33 kilonewton in this direction, then the wheel will topple over this rectangular block from point A. Is it clear?
Yes,
Any
sir.
doubt so far?
No, sir. No doubt.
Okay, so we have calculated this force P. Also in the question, it has been told to you that calculate this reaction force Ra, which this rectangular block is giving on this wheel. So for that, what I do is that I take the equilibrium point O. If I take the equilibrium point O, I can see that from point O, three forces are acting. One force is this 5 kilonewton weight of the wheel. Another force is this P, and the third force is this RA. This is my RA. Then if I know the angle between all the forces, then by Lami's theorem we can find out the value of RA, or else we can use the equations of equilibrium. Fine. Okay, and we know that this angle is theta. If this is theta, if this is theta, definitely this angle is also theta. Yes or no?
Yes, sir.
Because if this is theta 30 degree, definitely this is also 30 degree. If this is 30 degree, if this is 30 degree, you can see this RA and P is making an angle 90 degree. That means this is your RA, this is your P. That means this angle is also 90 degree. If this is 90, this is 30. Can you tell me how much is this angle? How much is this angle? Hello. This angle is how much? It is how much? This angle? 60 degree. Yes or no? If this is 30, in the question it has been told to you that this force P and this RA is making 90 degree angle. That means this is that force P and this is RA, outward RA. That means this angle is also 90. If this is 30, this is 90. If this is 30, definitely this will be 60, because this entire angle is 90 degree. Yes or no?
Yes, sir. Yes, sir.
Fine. So we have got, see, this angle is a 60 degree, this angle is theta, which we have already calculated, and I know that angle between P and RA is 90 degree. If that is the case, if this is 60, that means angle between P and RA is 90. So then this angle will be how much? This angle will be 30 degree. Now let us use the equations of equilibrium. So what I am doing is I am taking summation fx equal to 0. If I take fx equal to 0, then this is RA. See, this is your RA, and this angle is theta. That means if this is angle theta, then I will go like this, I will go like this will be RA cos theta, this will be RA sin theta, and this is 30 degree, this is the tail end of the force, this is the head end of the force, so I will go like this, upward and negative x. This angle will be how much? This angle is P. This angle will be how much? This angle will be P cos 30,
P
and
cos 30.
will be P sin 30. So I can see that, so I can write the equation. This is RA cos theta minus P sin 30 equal to 0. There is no other force present along x-axis. Theta already I know, that is how much? 30 degree. we have calculated. So RA becomes P sine theta, P sine 30 by cos theta. So P we have calculated 4.33 Newton into sine 30 divided by cos of theta. Theta is 30 degree. If you solve it, you will get the value of RA to be 2.499 kilonewton. Is the problem clear to all of you?
Yes, sir.
Any doubt so far? Hello. Any doubt?
No, sir, no doubt.
Okay,
Okay.
okay, fine. Last problem of this topic. It is little bit a tricky problem. That's why I have taken it lastly. Fine. With this topic, we will complete this chapter. Read the problem carefully. The problem is a cylinder of weight W. Okay, this is a cylinder, and from its center of gravity, weight is acting vertically downward. And radius R, radius of the cylinder is R, is supported in horizontal position against a vertical wall. This is a vertical wall. This AC is vertical wall. On this vertical wall, the cylinder is supported against in horizontal position against a vertical wall by a bar AB of negligible weight. The other end of the cylinder is supported by this inclined bar AB, whose weight is negligible, but the length of the bar is L. The bar is hinged to the wall at A. The bar is hinged to the wall at A and supported at B by a horizontal rope BC and supported at B by a horizontal rope BC. That means this bar is connected with this vertical wall by a horizontal rope BC, which will exert a tension. If I draw the free body diagram, find the values of angle theta that the bar should make with the wall so that tension in the rope is minimum. Assume frictionless condition. Now this bar AB is making an angle how much? The bar AB is making an angle theta with this wall AC. So what should be the value of this angle theta so that tension in the string BC becomes minimum? Is the problem clear to you? Is the diagram clear to all of you? Hello.
Yes, sir. Yes, sir.
Is it clear? So that means what I need to do is that first of all, I need to find out the value of tension T in terms of theta. You have to find out the value of tension T in terms of theta. Then, if you differentiate this expression of T, which is in terms of theta, and if you equate it equal to 0, that means dt by d theta if we do, and if we equate it equal to 0, we will get a particular value of theta, and that particular value of theta is what? Minimum value of theta. At that minimum value of theta, tension T will be minimum. Is it clear? Any doubt so far?
No, sir, no doubt.
Fine. So let us find out the tension T, which should be a function of theta. But before that, let us draw the free body diagram of this problem and let us try to find out all the unknown quantities. So firstly, I am drawing the free body diagram of this cylinder. What all forces will be acting from the center of gravity? This weight of the cylinder is acting vertically downward. The cylinder is attached with this vertical wall at point E. So the wall at point E will exert a reaction to the cylinder in this direction, that is RE. Similarly, this cylinder is in contact with this inclined bar AB at point F. So bar AB at point F will give a reaction RF in this direction. So this is the free body diagram of this cylinder W, RE, RF, and this RF is making an angle this theta. That means this is that diagram. Is it clear? The free body diagram of the cylinder. Any doubt?
No, sir, no doubt.
Fine. So from this expression, from this particular free body diagram, we can find out some unknown quantities. Let us find it out. So if this is RF, this is theta, then this RF will have two components. That means this is the tail end, this is the head end, and this is angle theta. So if I made a triangle, it will be like this. This will be the triangle. That means I have to go upward, and from this point I have to go in left direction. If this is RF, then and if this angle is theta, then definitely this value will be RF cos theta, and this value will be RF sin theta. And if I take summation Fy equal to 0, I can write this plus RF sin theta minus W equal to 0, or RF is equal to W divided by sin theta. Equation number 1. Any doubt? Any doubt so far till equation number 1?
No, sir, no doubt.
Okay. So by drawing the free body diagram of this cylinder, we calculated the value of RF in terms of W and theta. Now we can see that in this particular problem, the two objects are there. One is this cylinder, another one is this inclined bar AB. Now, if I draw the free body diagram separately for this inclined bar AB, let us draw the free body diagram for this inclined bar AB separately. We can see that at the end point B, tension will be exerted. This is that tension T. Then the bar is in contact with the cylinder at point F. So cylinder will exert a reaction back to the bar along the line of action OF. That means this will be the reaction. This is your RF. See, this is my RF, and since point A is a hinge point, that means about point A this bar AB can rotate freely. So along the line of action AO, the reaction of the hinge will be present. This is the reaction RA. So this is the complete free body diagram of this inclined bar AB. RA, this RF, tension T, and this particular angle is theta. That is this angle theta. Is the FBD of bar AB clear to all of you? Is the FBD of bar AB is clear to all of you?
Yes, sir,
Yes,
yes,
sir.
sir.
Okay, so now from this FBD, again we will try to find out some unknown quantities. Let us try to find it out. So I can see in the figure very clearly that the entire body can rotate about point A. Yes or no? From the diagram, it is very much clear that the entire body can rotate about point A. Yes or no? Hello.
Yes, sir, yes, sir.
Yes, sir.
Means I can take moment about point A. So if I take moment about point A for this bar AB, what I can write? That means tension T into perpendicular distance till point A. That means tension T into AC, and this T into AC is making the bar to rotate in this direction, that is anti-clockwise direction, and I have taken that anti-clockwise direction to be positive. That means clockwise direction I have to take negative. So the moment at point A due to this tension force is T into AC. Is it clear? T into AC. Any doubt? Hello.
No, sir, no doubt.
Okay. So and next is T into AC. Next is RF will give a moment at point A, and that moment will be RF into perpendicular distance till point A, that is AF, RF into AF, and this RF into AF, what will do? It will try to rotate this bar AB in clockwise direction. Since anti-clockwise we have taken positive, we have to take clockwise moment negative, that is RF into AF. See, RF minus RF into AF. Will I take any moment of force that is passing from point A? T into AC for this tension in the string. T moment about point A is T into AC. For this RF, moment about point A is RF into perpendicular distance AF. Now there is one more force, that is RA, which is passing through point A. Will I take the moment? Yes or no? Will I take the moment?
No, sir.
We will not take the moment because there is no perpendicular distance of the force RA which is passing through point A. That means my final equation becomes T into AC minus RF into AF is equal to 0, or we can write T is equal to RF into AF by AC, equation number 2. But we want to find out equation of tension T in terms of theta. That means again we have to use some geometry to convert RF, AF and AC into theta, because then only we will differentiate that expression, we will make it equal to 0, and then we will get the minimum torque and minimum angle. So in order to find out the values of RF, AF and AC, what we are doing, we are considering triangle ABC, this triangle ABC. If this angle is theta, I can write cos theta equal to base, that is AC, divided by hypotenuse AB. Cos theta is AC by AB. So we can write AC is equal to AB cos theta. And what is AB? What is AB? You check, AB is nothing but the length of the inclined bar L. So in place of AB, I can substitute L. So I get AC is equal to L cos theta, equation 3. See, we have converted AC in terms of theta, that is L cos theta, equation 3. Is it clear? Any doubt so far?
No, sir, no doubt.
Fine. Similarly, by somehow we have to convert AF also into theta. We have also convert AF into theta. So let us try to convert. In order to converting AF into theta, I am taking triangle AOF. Triangle AOF. That means this triangle AOF. This triangle I am taking triangle AOF. This angle is theta by 2. If I write cot theta by 2, that is cot theta by 2, we know that tan theta is P by B, that is perpendicular by base. So cot theta will be B by P. So cot theta will be B. B is what? AF divided by P, that is OF. So I can write cot theta by 2 equal to AF by OF. So cot theta by 2 equal to AF by, what is OF? What is OF? Can you tell me the value of OF from the diagram? Can you tell me the value of OF from the diagram? What is the value of OF? OF is nothing but the radius of the circle. It is nothing but the radius of the circle. That means 600, that is nothing but the radius of the circle, that is small r. So I am writing AF is what? AF is what? AF is OF. OF is what? OF is small r. So I can write AF is equal to r cot theta by 2, equation number 4. Is it clear? Equation number 4. AF is r cot theta by 2. Any doubts?
No, sir, no doubt.
Fine. So AF is what? AF is r cot theta by 2. Now if I substitute AC and AF in equation 2, I will get T is equal to RF into what is AF? AF is r cot theta by 2 divided by what is AC? AC is L cos theta. So T is RF into r cot theta by 2 by L cos theta by 2. Now this RF, this also we can substitute. We have to substitute in terms of theta. For that, you see equation number 1. In equation number 1, RF is already written in terms of theta. That is RF is equal to W by sine theta. So this value of RF, I will substitute over here. Then the tension T becomes W by sine theta into r cot theta by 2 divided by L cos theta. Or I can write T is equal to W into r cot theta by 2 divided by this sine theta. By trigonometry I can write 2 sine theta by 2 into cos theta by 2 into L cos theta. So just solve it, that is W into r cot theta by 2 divided by this expression. So in divided by 2 sine theta by 2 into cos theta by 2 into L cos theta. Now from this expression what you can do? You can cancel out this cos theta by 2 and this cos theta by 2. Then the final expression becomes W into r divided by sine theta by 2, W into r divided by sine theta by 2, then whole divided by this expression, or into 1 upon this particular expression, 2 sine theta by 2 cos theta by 2 into L cos theta. This cos theta by 2 cos theta by 2 cancel, or I can write T is equal to W into r divided by 2 into L cos theta into sine into sine is sine square theta by 2, equation number 5. Is equation number 5 clear to all of you? Any doubt so far?
No, sir, no doubt.
Only simple trigonometry I have used. I have minimized, means I have to solve it to the maximum level, so that in that equation of tension T, theta should be present, or else I cannot minimize it. Now if you see the diagram, so that is equation number 5. Now if you see the diagram, fine, the theta can vary from theta equal to 0 degree to theta equal to 90 degree. When the value of theta is 90 degree, the bar AB will exactly coincide with the vertical wall AC. Yes or no? When this theta is 90 degree? Sorry, yes, this bar AB, it is varying like this. It is varying in this manner. That means this is theta equal to 0 and this is at 90 degree and this is 0 degree. When the value of theta is 0 degree, the bar AB will coincide with this vertical wall AC. Yes or no? Hello.
Yes, sir, yes, sir.
And when the bar AB is and when this theta is 90 degree, when this theta is 90 degree, position of bar AB will be this position. This is the position of the bar AB, and angle is how much? 90 degree. That means the value of theta can vary from 0 degree to 90 degree. In between, there is some value of theta where tension is minimum. That minimum tension I need to find out. In order to find out that minimum tension, since if you see this expression, equation number 5 is a function of theta. So if I differentiate equation number 5 with respect to theta, and if I equate it equal to 0, I will get one value of theta, and that value of theta will be the minimum value of theta corresponding to minimum tension. Is it clear?
Yes, sir.
Fine. So let us differentiate equation 5 with respect to theta. That is dt by d theta equal to 0. So I will not show you once again the differentiation procedure. It is nothing but x by y, d by dx of x by y. You know the formula. Just apply the formula and just do the differentiation. Once you do the differentiation, the final result becomes T is equal to W into R divided by 2 times of L cos theta into sine square theta by 2. That is equation okay, dt by d theta. So yes, if I do this dt by d theta and equate it equal to 0, I am getting the value of theta coming out to be 60 degree. So this is my expression t, which is dependent of angle theta. Next, what I need to do, I need to differentiate equation 5 with respect to theta and equate it to 0. So dt by d theta equal to 0. If you do it, you will get the value of theta coming out to be 60 degree. That means that 60-degree angle is that minimum angle where the value of tension T is minimum. And what is the value of tension, minimum tension? Now, if you substitute this theta equal to 60 degree in this expression, equation number 5, if you substitute theta equal to 60 degree, you will get the value of tension which is minimum in the problem, and that is what we have to find out. So W into R divided by 2L cos 60 into sine square 60 by 2. So if you do it, you will get the minimum tension value coming out to be 4WR by L. Is the question clear? Any doubt in this problem?
No, sir, no doubt.
Fine. I know this problem is little bit tricky, a little bit tough, but if you know the how to draw the free body diagram, and if you can or if you can make out the correct meaning of the statement, then it will not be tough. Okay. So with this, I end this module over here. I have made you solve enough problems, near about 20 to 25 problems I have made you solve in this module. So you please refer I will post the entire PPT today itself in the Google Classroom. Fine. You can go through my PPT, you can go through the book also, because you can expect that since it is an online examination, so all of you know that you will be available with resources, that is with Google, with books. So you can expect that the same question I may not ask in the neither in the end in this mid sem. So accordingly you just prepare your topics. Concept is same, everything is same. Maybe the diagram may be different, or language of the, or if I'm asking the same question, I will just I will change the language, so that then I should know that yes, whether you are picking the question correctly or not, like that. Okay? Any doubt? Hello.
Sir, can you please repeat the mid-sem syllabus once?
My part syllabus is this module, complete this module.
Okay,
Hello.
okay, sir. Okay, sir.
And from SBM sir's part, CG and MI, moment of inertia and center of gravity. And from my part, this module. Okay?
Okay, sir.
Okay. So next we will meet on Wednesday, and that Wednesday, if you are facing any kind, you go through the book, you go through my notes completely, solve the problems. If you face any kind of doubt, you can ask in the Wednesday's class. Then I will keep that Wednesday's class as a discussion session, or else I will start with the new module, that is friction. Fine. But once again, I'm telling you every time, please practice, because mechanics is like concept. You cannot memorize each and every question, because each and every question, the concept is different.